second. So remember that this diagram, the diagonal lines, as we follow those diagonal lines up, that's the order they fill up. That S's can hold up to 2, P's can hold up to 6, D's can hold 10, and F's can hold 14. And the filling order is this way because that's a quick and easy way to recreate the actual energies. So this just makes this order show up. So this is the reason, this is the way we remember it. Easy. Does that make sense? So let's do the electron configuration for barium. Okay. So barium, find on the periodic table, is number 56. So I have to describe where 56 electrons are going. And all we have to do is follow in order and keep track of where we're at. So I start at the bottom. First thing I run into is 1s, and 1s can hold 2 electrons. That takes care of my first line. Second line goes through 2s, and 2s can hold 2. Now I'm up to 4 of my 56 electrons. I'm not done yet. So my next diagonal line, following it up, goes through 2p, and 2p can hold 6. All the p's can hold 6, so now I'm at 10 electrons. Then next comes 3s. There's 2, that's 12 electrons. Then I need to go to the next line. The next line goes through 3p, that holds 6, there's 18. And then 4s, that holds 2. Notice 4s fills up before 3d. It's really about the fact that 4s is lower than 3d. The diagonal lines just take care of that for us. Oh, now I'm at 20 electrons. Got to go to the next line. 3d, add 10 more, there's 30. 4p, add 6, that's 36. 5s, that's 2, 38. Next line. 4d, d's hold 10. So that's 48. We're getting close. Then 5p holds 6. That's 54. And then 6s can hold 2, and that's 56, which is what I was looking for. So I'm done. Now, I will never ask you to do this, but I want you to know that your book does this. Your book will take this configuration and rewrite it. And it'll put all the 1s together first, 1s2, then all the 2s, 2s2 and 2p6, then all the 3s, 3s2, 3p6, 3d10, then all the 4s, 4s2, 4p6, 4d10, then the 5s, 5s2, and 5p6, and then the 6s. I prefer this one. Your book occasionally writes that one. Watch out for that. Okay? And where it's going to mess you up is if you see 6s, you need to go back to see what's happening with, is there a 5d there? Because the 5d may not be full. Okay with that? Okay, so which one of these is the electron configuration for chlorine? Okay, what we get for answers? Okay, so the correct answer is you get to 17. The only one that gets you to 17 correctly is D. There is no 1p, so that can't be right. And that can't be right. And that can't be right. So once you saw the 1p, you knew things that you're down to 2 of them. Okay? And in C, they forgot 2p. That's where they went wrong. They forgot the p's. Okay? Extra super tough. Just keep track of where you're at along the way. Okay? Okay, a second way of showing the electron arrangement is an orbital diagram. An orbital diagram. Okay. So it's really just our off-bow diagram flattened out. So instead of going up, you just move the pieces over. And instead of writing whole boxes, you just write a line. So a short line for each orbital. So S's get 1 line, P's get 3 lines, D's get 5 lines, F's get 7 lines. And you group them together. So I got 1s, I got 2s, 2p gets 3 lines, 3s gets, so it's the same order. We're just going to present the information in a different way. This is the second way of looking at the same stuff. And we're going to use arrows just the way we used them in the orbital diagram. It's the same order. Okay. So it's just going to be, see how I really just took 1s, then moved the 2s next to it, then the 2p next to that, then the 3s. So instead of going up, they go sideways. Instead of just writing little superscripts, we draw arrows. So what element is going to have that orbital diagram? It's actually really straightforward to do. Each arrow is an electron, right? So I see 8 electrons there. Just count. What has 8 electrons? O has 8 electrons. Oh, it has 8 electrons. Okay. So see how this is just another way of writing 1s2, 2s2, 2p4. But the difference is, here I can see that these electrons are unpaired. So, let's do the orbital diagram for carbon. Well, starting from the bottom, first I have a 1s. It gets one line. And carbon is number 6, so I got to go to 6. So there's my 2 electrons in 1s. That's what I fill up first, 1s. Then my next diagonal line goes through 2s, so I need one line for 2s. And that only gives me 4 electrons, so I'm going to fill it up. You've got it on the pink paper. Don't spend all that time. Okay. Then the next line goes through 2p. And for 2p, well, I only need 2 more electrons, so do I just have to draw one line? No, you always, for p's, you always draw 3 lines. And I only need 2 electrons. And we use Hund's rule. They don't pair up until they have to put them in separate orbitals. Electrons would not want to be in the same space because they've got the same charge. So if they can arrange themselves so they're not next to each other, that's where they're going to be. They don't pair up until they have to. Okay, really tough? Let's just do it for magnesium. So, magnesium is number 24. So I'm going to draw 24 arrows. No, it's not. No, that's manganese, it's 25. It's number 12. I didn't think I got to 24. 24 is way too many. We tend not to write orbital diagrams for things, with 70 electrons. We could, but we don't want to draw that many lines. But first I'm going to go into 1s. It's going to get 2 of my 12 electrons. Then the next diagonal arrow goes through 2s. And it's going to get 2 electrons. The next line is going to go through 2p. 2p gets 3 lines. And I'm going to fill them all up, because that gets me to 10 electrons. Then I get 3s, and it gets 2, and that's my 12 electrons. Right? 2, 4, and 6 is 10, and 2 more is 12. Extra fancy. Okay. Now, just because we run into it a couple times already, one little detail about the periodic table. Actually, 2 details. And just so we can talk about it intelligently. The vertical columns is redundant. All columns are vertical. Up and down. Those are officially known as groups. Okay? In the first group, it says 1A over it, so that is group 1A. Second column is called group 2A. Way, then there's 3B, there's 2B. So a group is a column. And the periods are the rows. And those are labeled period 1, period 2, period 3, or if they're getting fancy, the fourth period. Now, A's and B's, we'll talk about why the A's and B's are there later, okay, on the columns. So, what is the group and period of sulfur? So you got to find period, you got to find sulfur. It's number 16. So, what group is it in? Well, I go up to the top and it says group 6A. What period is it in? 1, 2, 3. It's in the third row. Period 3. The third period. So what is the group and period of barium? It's just a matter of knowing which one's a group and which one's a period. And the group was 2A. And the period, 6th. Period 6.